Welcome to datascience.show, the podcast where data science meets executive leadership. We talk with top AI and analytics thought leaders about turning data into real business impact. If you're a C-level leader or data expert shaping the future, you're in the right place.
I'm your host, Mirko Peters. We explore how data science and AI drive real business impact, straight from the leaders making it happen. Today, we tackle a deceptively simple but critical question. How do you keep business running when machine learning systems fail? Operational resilience for ML is not an engineering hobby, it's an executive priority. In regulated industries and real-time services alike, model failure becomes business failure unless you design for continuity. In this episode, I'll give you a C-level playbook, business-aligned SLOs, observability that maps to revenue and risk, incident runbooks that actually work under pressure, chaos testing for data pipelines, and the ownership and FinOps decisions that determine whether resilience is sustainable. My promise? Practical controls you can prioritize in the next 90 days, so AI keeps delivering even when models don't.
Before we dig in, let's sketch the environments where resilience matters most. Picture three familiar contexts. Retail e-commerce that runs dynamic pricing and inventory recommender systems. A retail example where a pricing model drifts and suddenly underprices a popular product, eroding margin across millions of transactions. Picture a bank using credit scoring models for lending decisions. Data drift after a macro shock can change applicant populations overnight and increase default risk. Or a telecom provider with churn and network optimization models, where pipeline latency or a feature service outage degrades routing decisions and causes dropped calls. These are not theoretical. These are the incidents that drive resilience programs.
Scale and role matter. If you're a CDO or CTO, you care about board-level continuity, revenue at risk, regulatory obligations, and reputational damage. For heads of ML engineering or production ML teams, it's about minimizing mean time to detect and mean time to recover, and ensuring the alerts you get are actionable. For senior data scientists, resilience means designing features and models that fail safely. Across these roles, the unifying requirement is simple: tie technical signals to business outcomes and make response predictable.
Let's move from context to a practical strategy to execution map. First control, enterprise SLOs for ML. SLOs stop technical noise from overwhelming decision makers. Don't create SLOs for every metric. Create them where business value is at stake. Examples: false positive rate on fraud models with dollar exposure thresholds. Latency SLO for real-time feature lookups tied to customer experience KPIs. Revenue at risk windows for pricing models. An SLO is a contract. The business impact you agree will be met. Measure it and instrument alerts that escalate only when SLOs are violated, not when low-level metrics wiggle.
Next, observability that matters. Shift from raw telemetry to signal hygiene. Track data drift, feature distribution skew, label delay, prediction confidence decay, input schema changes, and upstream throughput. But critically, correlate those signals with business KPIs. A rising data drift metric is a warning, but if it correlates with a 5% increase in chargebacks or a 10% fall in click-through, it becomes an incident. Build dashboards that show both technical and business views side by side, so triage teams can prioritize impact quickly.
Alerting and on-call design. Avoid alert fatigue by routing to the right role. Low-level infra alerts go to SREs. Feature skew and model quality alerts go to ML engineers. Business impact alerts, SLO violations, should ping a cross-functional incident lead who can decide triage and remediation. Define escalation ladders ahead of incidents. Who owns rollback authority? Who calls for human-in-the-loop gating? And when to route to legal or compliance. Practice runs so the sequence is muscle memory, not improvisation. Runbooks and playbooks are non-negotiable. A good runbook answers 3 questions in the first minute. What happened? Who is the incident lead? And what immediate containment steps exist? Include clear decision criteria. If false positive rate greater than X and revenue at risk greater than Y, then trigger rollback or deploy a fallback policy. Keep playbooks short.
Humans operate under stress, so checklists should be readable in 30 seconds. Pair runbooks with automated play triggers for low-risk remediations and human gates for high-impact decisions.
On automation versus human intervention, automate containment that is deterministic and reversible. Switch to cached features, fallback models, or routing logic that uses last known good decisions. Keep humans in the loop for ambiguous, high-impact choices. In control quickly. The paradox is this. More automation can reduce time to recover, but increases the need for robust testing and guardrails.
Chaos testing for ML systems is effective when it targets real failure modes, corrupt features, delayed labels, third-party API degradation, and adversarial inputs. Run controlled experiments that simulate these conditions against staging and production-mirrored environments. Measure recovery times and validate runbook steps during drills. Importantly, test the communication chain, alerts, incident channels, and executive summaries, and tune them until they produce calm, actionable responses instead of panic.
Cost trade-offs are often the hardest executive conversations. Quantify cost of downtime, lost revenue, remediation cost, regulatory fines, and reputational impact. Compare that to the cost of redundancy, replicated pipelines, cached features, and warm standby models. Use decision thresholds. If expected loss over a year exceeds the annualized cost of resilience, invest. For smaller teams, use phased investments. Protect the highest value models first and adopt lightweight fallbacks for lower impact systems.
Now, the organizational layer. Ownership models should be explicit. Production ML outcomes require joint accountability between product, data science, ML engineering, and SRE. A practical pattern is a named service owner accountable for SLOs with a supporting on-call rotation across ML engineering and SRE. Create a cross-functional incident review board that runs blameless post-incident reviews and drives prioritized remediation backlogs. Incentives matter. Align performance metrics so teams aren't rewarded for optimizations that increase systemic fragility. Executive KPIs should be simple and outcome-focused. Number of SLO breaches, mean time to detect, mean time to recover, and business exposure during incidents. Report these quarterly with trend lines and remediation progress. For boards and auditors, present scenario-based risk assessments. What happens if a top model degrades for 24, 72, or 168 hours? That framing converts technical work into strategic decisions and budget requests.
Looking ahead, 3 durable risks deserve attention. Adversarial inputs that deliberately exploit model behavior, third-party data or vendor failures, and tightening regulatory expectations around explainability and continuity. Defenses are straightforward in concept: adversarial testing and robust feature validation, contractual SLAs and vendor redundancy, and documented contingency plans that satisfy regulators. Prioritize the highest likelihood, highest impact risks in the next 12 to 24 months, not everything at once. Before we close, 2 actionable insights you can take to the executive table right now. First, establish an enterprise ML SLO for a single high-value model this quarter. Define the business metric it maps to, set thresholds, and instrument alerting. Second, publish and exercise a short incident runbook for that model, containment steps, rollback criteria, and a communication plan. These 2 actions create immediate visibility and reduce tail risk rapidly.
Final reflection. Resilience is more than redundancy. It's the discipline of tying models to measurable business outcomes, then designing predictable responses when those outcomes drift. Culture and accountability win where tools alone fail. Build muscle memory through drills, keep human decision paths clear, and let your SLOs do the prioritization work. That's the difference between models and value. If you found this episode valuable, subscribe and share it with your network. And let's connect on LinkedIn. I'm Mirko Peters. We'll be back with more conversations on how data science and AI create real business impact. Until next time.
Thanks for listening to datascience.show. If you found value in this episode, subscribe, share it with your network, and join us next time as we explore how data science drives smarter decisions and better business outcomes.